All right, this is chapter 9, lesson 3. We're still in area, but now we're going to deal particularly with the area of a triangle. All right? Who remembers the formula for the area of a triangle? Hannah?
Is it 1/2 base times height?
Yes, it's 1/2 base times height is the area of a triangle. Now, our base and our height will look different depending on what type of triangle it is. What are the types of triangles that we have? What's one?
Right.
We have a right triangle. With a right triangle, what is my base and what is my height? Will? The legs. That's right. So we have two legs and a hypotenuse. So it's 1/2 times one leg times the other leg. All right. What's another type of triangle that we have? Yes, Dylan?
Isosceles.
We have an isosceles. When we have an isosceles, what would be, looking at that triangle, what would be the name of that, another name for this triangle? Yes?
An acute triangle?
It's an acute triangle. When we have an acute triangle, you just choose one of the sides to be your base. Your height goes from the vertex of the opposite side of the base perpendicular to the base. So that's your height. It is also referred to as your altitude. All right, so here your height is going to lie inside the triangle. Here your height lies on the leg, right? Your height lies on one of the legs. With an acute triangle, your height lies inside of the triangle. There's one more type of triangle in terms of angles. We have a right, we have an acute, and then we have an obtuse triangle. There is an obtuse triangle. So if this is my base, there's this imaginary line that continues, and my height goes from the vertex opposite the base. This is still the vertex opposite the base, but it goes perpendicular to the base such that the height lies outside of the triangle when it is obtuse. So right, the height lies on the leg. Acute, the height is inside. It goes from, if I'm looking at this side being the base, the opposite vertex perpendicular to the base. If for an obtuse triangle, if this is my base, it goes from the opposite vertex perpendicular to the base, but lies outside of the base. All right, so look on page 352. There are some theorems. The first theorem says the area of a triangle is half the product of its legs. It's 1/2 the product of its legs. Product means you are multiplying. And for both of these other two triangles is theorem 39. It says the area of a triangle is half the product of any base and its corresponding altitude. So the corresponding altitude is from the vertex opposite the base, perpendicular to the base. Now we can have triangles that look nothing alike, but the length of their base and the length of their altitude is the same. So I could have a right triangle, I could have an acute triangle, and I could have an obtuse triangle, and the lengths of my base could all be the same, and the lengths of my altitudes could all be the same. Those triangles are not congruent, are they? They're not. However, if they have equal bases and equal altitudes, then their areas will be equal. Any triangles, even if those triangles are not congruent, if they have the length of their base is the same and the length of their altitude is the same, then they will have the exact same area.